Hello everyone. Well, I'm gonna make a video today to discuss about the bisector planes and lines or segments with equal angles or equal distance to different planes. For example, if I'm making here a 3D sketch and I can plot here whichever line. I'm gonna model it a bit, and they ask me that this line need to be at the same distance with this plane, with the top plane, for example, and the front plane and top plane, or at the same, or this line needs to form the same angle with both planes. I could do many things. I could always go to the traditional form, like for example, if I have a line and I want the line to have the same distance with two planes, and this line is made by 2 points, the initial and the end and the final point, and if both points are at the same distance with both planes, that means that every point at the line have the same distance. So for example, I could go and make, for example, from this segment to that plane, from that point, and from here to there, and then I could make this point on this plane, this point on that plane, this segment perpendicular to the plane. Doesn't let me do it, I don't know why. Yeah, because it's already, I need to model it, yeah, because it's already in the plane. That's fine. Okay, so this segment is perpendicular to the front plane, and this segment is perpendicular to the top plane. Perpendicular. Okay. So as we saw in the theory, the distance from one point to a plane is defined by a segment perpendicular to the plane. So if I say that these two segments are equal, that means that this point is at equal distance from both planes. I don't know exactly the distance, but they are equal. And I could do the same with the other one. I could do exactly the same. Yeah. For example, I could make a sketch. Yeah. One line, another one. And this point needs to be on that plane. This point on the top plane. I need to model a bit more the line and the points. I model it just to avoid errors with the SolidWorks. And this is perpendicular, and this one perpendicular to the top plane as the definition of the distance between one point and one plane. And I can say that this distance and that distance are equal. Yeah, that doesn't mean that this distance needs to be the same as this one, but this line is not fully defined, but it's a line that has the same distance all points with the front and the top plane. Yeah, and that's one way to do it. Yes. But there is a different way to do it, which is essentially easier, and we have discussed it in class already, which is the bisector planes. So for example, if I go here to features, I can make a reference plane between the front plane and top plane. Yeah, and I have this one. Yeah. So this is a plane. It is called, I think, plane 1. Well, we'll put the name later. That has the same, same angle with both planes, and any point here is at equal distance with both planes. So I have this solution, but I have also that solution, yeah, which is in the first quadrant on the second one. Yeah, depending on which one solution you want. Okay, but this is not the only solution. I could have more. For example, any plane parallel to that one, any plane parallel to this one, I'm gonna say parallel, I'm gonna put it, well, here I'm gonna put at a distance, you know, any plane parallel to that one also have the same definition, is that it is at equal distance from the front plane and the top plane and has the same angle. Yes. So for example, if I have a 3D sketch now and I define a line and I put this line, for example, on this plane, yeah, so this line has the same distance, well, not this one because it has the same angle, this one has the same angle with the front plane and the top plane, but there is in this one, which is the bisector, I'm gonna put it on plane. This one has the same distance with the front plane and the top plane and front plane and the same angle, and here in this case have the same angle, yeah, but not same distance because it is not going this plane from the origin. Yeah. Okay, so you know, using the bisector planes is something it's always very useful because it saves a lot of time. Yeah. So these two planes, the plane 2 and 3, we said that they have formed the same angle with these two planes, front plane and top plane. Yes. So this is a condition which is just sufficient. Yeah, it's sufficient. So any plane like this parallel to this one have the same angle, but not necessary. I mean, you know, I could get another plane with same angles which is not exactly that one. Yeah. So for example, I can show you, if I hide all these things, and I do a 3D sketch, yeah, I have a 3D sketch, and then for example I make a plane, yeah, this one, I'm gonna move it later. Okay, I have this plane and I'm moving this plane. I'm gonna move it, yeah. Okay, so I have this plane which is not parallel to any of these, but equally I can make this plane form the same angle with the for example with the top plane and the front plane. Yeah. And in this case, yeah, I will have to do the typical construction to get an angle between two planes. For example, I will need to find the intersection line between this plane. No, if I'm gonna use the top plane, I have to go somewhere here. You know, I need the intersection line between this plane and the top plane. And I need to find the angle which is made by a line perpendicular to the intersection on my plane, perpendicular, and also perpendicular in the top plane. Okay, so this is, and this one is perpendicular, yeah, and I can get the angle here. For example, I could measure an angle, and we said that if we want to make angles equal, we need to do an arc. So if I try to do an arc, it is a bit difficult because, for example, I have this point, but I need to make it coincident with that line. In this case, I can, but sometimes it's not that easy. Yeah. So here is where I will measure the angle, and then I do the same So this is with the angle between this plane and the top plane, and I can make the same with the front plane. Yeah. So the sketch line. So I said that this line is in the front plane, and equal here I will put the angle between the front plane and my plane. So this line is perpendicular, and I have to do the same in the front plane. And this is perpendicular. So if I want to make these angles the same, I have to do the same an arc, and check if I can find this arc. You know, this is the difficult thing, is to make this line coincident with this segment. And sometimes SolidWorks has problems to do that. I don't know why these things move it. This is with the front plane. Yeah, so what things that we can do to solve that. Yeah, I have moved the plane parallel to the front. I'm gonna modify these things. Yeah. Sometimes SolidWorks does funny things. Yeah, I have moved the plane parallel to the top plane. Yeah, I'm gonna remove this in. Sorry, it's getting a bit messy. Yeah. Okay, I'm trying to make things a bit easier to understand. Yes. Yeah, sorry, but SolidWorks by itself move this plane parallel to the front plane. But anyway, so we have this angle. So if we want to make this arc, something we can do, we can make a plane between these two lines. Yeah, and one that I have that plane, I can make the arc and make sure that this arc is always in the plane between these two lines. Yeah. Okay. So what I want to do is to make this plane here, which is the one, I'm going to make it bigger, have the same angle with the front plane and the top plane. Yes, so you remember that we have to do these two arcs, same radius and same equal length. Yeah, so I click, control click, yeah, and I say equal, so that means equal radius and equal length. Yes, and by doing that I make that this plane one has the same angle with the front plane and the top plane. I don't know which angle is this one, because I can still move the plane. I can still move it, but anytime that I move it, both angles are the same. Yeah, for example, I could measure it if I want to. Should give the same 51 in this case, 0.14. 51.14. Yes, so the angle is the same, but I don't need it. But you know, I could get another condition to fix that plane or not. But yeah, this plane has the same angle with the front plane and the top plane. It is not parallel to those ones, but those planes, plane 2 and 3, they at the same time they have the same angle with the front plane and the top plane, yes, but they are not the only ones. So well, I hope this is helpful, and you can follow this easily. Thanks.